take a look at question 28. We are asked to identify which description represents a valid mathematical function. Before we can pick out the right answer, we have to ground ourselves in the strict mathematical boundary that defines what a function actually is. It's all about predictability and rules. The easiest way to visualize a function is to think of it as a machine, a consistent transformer. For every single item you put into this machine, the input, you must follow a dependable rule to produce exactly one result, the output. If you put the exact same item in twice, you must get the exact same result back. If your machine starts producing two completely different rules for the same input, it breaks the rule and is no longer a valid function. And this brings us to the core foundation of functions, the unique mapping principle. The absolute defining characteristics here is that each element in our input domain corresponds to exactly one element in the output range. Now keep this distinction in mind. Multiple different inputs can lead to the same output. For example, if you are squaring say, -2 and +2, both give you 4, which is perfectly fine, but a single input can never branch out to multiple different outputs. But what if we are not looking at raw data set? How do we identify a function when it's represented visually as a graph or geometric shape? We use a highly reliable tool called the vertical line test. To test a graph, imagine drawing a vertical line anywhere across the coordinate plane. If the vertical line intersects the graph at more than one point at any time, then the graph fails. Why? Because that single x value input is trying to claim multiple value outputs simultaneously. Now let's look at two classic failures. First, the circle. A circle completely fails the vertical line test because a vertical line passes through it twice at almost every point. One input gives us two outputs. Second, look at a dataset with infinite targets. Any mapping where one single coordinate point shoots out to infinite targets completely destroys the core requirement of input-output consistency. It's completely unpredictable. With these principles in mind, let's dissect our multiple choice options for question 28. Option A describes vertical lines crossing the baseline at multiple points. A vertical line itself represents a single x value with infinite values, the ultimate function failure. Let's take a look at option C. It mentions a circle, which we already know fails the vertical line test by mapping x values to two different arcs. Option D maps a single point to infinite targets, breaking the consistency completely. That leaves us with option B, which states an input-output relationship where every unique input maps to exactly one output. This is the verbatim fundamental mathematical definition of a function. Functionality equals uniqueness. When you point to an input, you must know with absolute certainty the single unique output it generates. Therefore, option B is our correct answer.